Hi, my name is Raunak Gupta, and I'm an undergraduate freshman at Carnegie Mellon University. And this is my term project for the course 15112. For my term project, I have made a nutrition and health tracking application which allows the user to input nutrition labels and keep track of their consumption of the key nutrients and food groups. To analyze the nutrition labels and obtain information from them, I have used and developed the K-nearest neighbor algorithm, the basics of which I've learned through online tutorials. This video is going to be split into two parts. In the first part, I will focus on the user experience, while in the second part, I'll go more into detail about the technical aspect of my project, especially focusing on how I modified and developed an algorithm to process information on a nutrition label. So now I'm going to go ahead with the first part of my video. So let's go ahead and sign up for an account. So I'm going to enter my personal email and also choose a password. So now that I've done that, the program's going to send an automatic email with a verification code so that I can verify that I'm the actual user. So here's the email, and here's the verification code that we need to enter. CG86 capital G SM capital C. And once you do that, it asks for your daily target intake of calories. So let's say my daily intake is approximately 1,500 calories. So now that's done, I can go ahead and log in. So I'm going to use my same email and the same password, and I'm in. So this brings me to this landing page here, which has two main buttons here, the food finder and the nutrients tracker. The food finder is where the user inputs their label for processing, whereas the nutrients tracker is where the updated information then goes to for graphical and for viewing as graphs. So let's go ahead and test the application out. So in my food finder, I'm going to input the name of the file that I want to process, including its extension as a JPEG format. So I have a bunch of demo labels saved in the same directory. So let's go ahead and put the first one in, called firstlabel.jpg. So as you can see, this may take up to a few seconds because it's going through the machine learning algorithm. And once that's done, the information has now been updated in the nutrients tracker. So if I go ahead over here, I can see that I'm looking at the data for today, and I've consumed these many, this much for each nutrient group, which is shown graphically. The recommended value line here is calculated for each nutrient over here using the recommended intake calories that the user inputted when they signed up. If I hover over each graph, it tells me the recommended value for of the nutrient for me. So as you can see, the recommended dietary fiber consumption would be 18.75 grams. So, and over here on the top, I can toggle between the different days and see data for the last 7 days, including the last week's average. Now, since I just signed up using this account, there is no data for the rest of the days. However, the last week average data does exist. There's also this button over here. So let me just go back to today. And over here, I can also track my intake of calories graphically as a circular graph, which fills up according to the total recommended calorie intake for the whole day. So as you can see from the first label that I inputted, I've consumed 45 calories for today. So now let's go ahead and test out a few other labels. So I'm going to click on the home page, which is going to bring me back to this landing page here. So now let's go ahead and input another label, which I have called fourth test on my computer. So once again, it's going to process and take up to a few seconds. And now we get this warning over here, which says that some values on the label that we just entered were not processed correctly. So it's going to ask us for those specific values manually. So let's go ahead and do that. So it didn't recognize trans fat. So let's just say I ate 1 gram of trans fat. There were 250 milligrams of sodium, 5 grams of sugar, 1 gram of carbohydrate, and 10 milligrams of cholesterol, 4 dietary fiber. And now if I go to my nutrients tracker, I can see that the nutrients have been updated according to what I've just inputted once again. There's also a third feature in my food finder where if a label that is inputted is not read, which is cannot be processed at all, the program then asks for the user's manual input. So here, I'm going to input a very low quality label that I've taken, which I took a picture of, and I'm going to go ahead. And it says that the label could not be processed, and I need to enter the values manually. So I'm going to go ahead and enter all the values manually. So let's say I ate 10 grams of fat. Let's say there was 9,000 milligrams of sodium, 50 grams of sugar, 240 calories, 20 grams of carbohydrate, 5 grams of trans fat, 1 gram of saturated fat, and 4 of that, and 10 of that, and 1 of that. And now, if I go to my nutrients tracker, it would have updated these values. Now, as you can see, the bar graphs for the sodium, sugars, and trans fat have changed to show the fact that the user has consumed over twice the daily recommended value. If I go over to my calories, I can see that the calorie values have also been updated, and so has the bar graph. So have the bar graphs of the last week's average, including the last week's calorie average. I'm going to go ahead and now demonstrate another feature in which the program sends automatic emails to the user once they consume too much of a certain nutrient group. So over here, I'm going to log into another account that I've already created. Actually, no, I'm going to log into the same account that I just had. So I'm going to do and once I do that, it takes me back to the landing page, and it realizes that I've already consumed more than I should have for the specific day. If I go to today, I have already consumed more than I should have for that specific day. So it sends me a warning email. And if I go over to my email, surely the email is right here. The email tells me the different food groups that I consumed on that day, telling me what my recommended value is and how much I actually consumed on that given day. So that brings me to the end of the first part of my video. Now that brings me to the second part of my video, in which I'll focus on the technical aspect of the algorithm that I used in my project. So if you're not interested in the technical part of this, now would be a good time to stop watching the video. So to process my nutrition label, I used OpenCV's built-in k-nearest neighbor algorithm. To use this algorithm, I had to first go through a training phase in which I taught the model what each letter and number looks like on the nutrition label for over 20 different fonts. I then stored this position data for each letter, which is known as a feature vector, in text files, which could then be input into the testing over here. So for the testing, I began by first splitting the label into individual snippets, which can each be processed and analyzed individually, one by one. When I get to looking at each individual snippet, I look through each letter one by one and try to match this letter's position vector to the position vectors that have been processed and put into my training, which have been stored in the text files from my training data. Using this process, I could then create a string of what the message for each snippet would look like and get a fairly close match.